We now have three rules according to derivatives. We have our exponent rule, we have our product rule, and we have our quotient rule. Exponent rule. When you have f of x equals ax to the n, our derivative is a times n, x to the n minus 1. That is our exponent rule. We have our product rule. Which is h of x, two functions, f of x and g of x. To take our derivative, this is f prime at x, the derivative of the first times the second, plus the first, times the derivative of the second. That's our product rule. And then we have the quotient rule. Our quotient rule deals when these two functions are being divided. F of x divided by g of x. So when we take our derivative, it looks exactly the same as what we just did here, but this plus turns into a minus. And then we divide that by our bottom squared. We have our bottom squared. That's our quotient rule. Well, what we have here is we have two functions f of x, or that two functions that are being divided. So we have 7x squared plus 8 over 3e to the x. So we have two functions being divided, so if we're dividing, that's our quotient rule. So we have the derivative of the top times bottom. So the derivative of the top, we just use our exponent rule, would be 14x plus 0. So we just have 14x times the bottom, which is 3e to the x, minus the top, 7x squared plus 8, times the derivative of the bottom. Well, the other day we went through by definition and derived the derivative of e to the x. The derivative of e to the x is what? E to the x. It's the same thing. So the derivative of 3e to the x is still going to be 3e to the x. And this is all over our bottom squared. So we have 3e to the x squared. Now if we take a look, this is multiplication here. This is multiplication here. What is a common factor that we have in all three terms that we can cancel out? 3e to the x. So this and this cancels with one of these. We had to be able to take the same thing out of all three of them. So we are left with 14x. This comes down to 1. This is 1. 14x minus 7x squared plus 8 over 3e to the x. And what I think I did, I probably distributed the negative through. So we have 14x minus 7x squared minus 8 over 3 e to the x. Other questions? Let's take a look at number 11 or 12. Determine a location where the tangent line or lines are horizontal. Well, if we take a look at number 11, we have f of x is equal to 2x cubed plus 9x squared minus 24x plus 6. And this makes us extend our comprehension just another step. I want to determine where the slope of the tangent lines, the location where the slope of the tangent lines are going to be horizontal. What do we know is true about the slope of horizontal lines? If I have a horizontal line, what is the slope of a horizontal line? What's the slope of it? Anybody?
0.
0. The slope is 0. If I have a horizontal line, the slope of a horizontal line is 0. Well, how do I relate slope to a function? Well, when I look at a function and I want to find slopes of tangent lines, what do we have to do with a function to be able to find the slope of a tangent line at any point? Ozzy? Not plug it in yet. I want to find the slope of a tangent line. Problem number 9, how'd you find the slope of the tangent line? Problem number 10, how'd you find the slope of the tangent line? What'd you have to do? Take the derivative. We take the derivative because the derivative will give us the slope of a tangent line. So let's take our function and take the derivative of it. Go ahead. If you haven't done it, do it. Take the derivative of our function. Ozzy, what do you get?
6x squared plus 18x minus 24.
And what we want to know is where is the slope of the tangent line equal to 0, because that will give us horizontal lines. So now we have a quadratic equation to solve. So if I take a look, how do I solve this? What's the first thing we could do to solve this? Factor out of 6. So we have 6x squared plus 3x minus 4 is equal to 0. And then we can factor down our two factors there. Brandon, what's the two factors?
X plus 4 and x minus 4.
So our tangent or our points would be at x equals -4 and x equals 1. So if I take a look at my graph, if I would draw tangent lines through my graph, at x equals -4 and x equals 1, I would have a horizontal tangent line. Well, I'm asking for the location of this, so we need a y value. How do I find the y value? Yeah, plug it back into your original function. So I had to go to my function at -4 and our function at a value of 1. I typically, whenever I have a function I have to deal with, I'm clickety-clacking that into my calculator to begin with, because I don't know if I have to evaluate something. Then we can find our y values. Once again, just a little bit more of an extension of what we've been dealing with. What's our two y values, Carmela?
118 and -7.
So the location where we have horizontal tangent lines are -4, 118, and 1 and -7. Once again, just something a little bit different. Any other questions you have? Alright, what we have today will just be an in-class assignment. Nothing else for you. Where this will lead to is a review day on Monday and a quiz on Tuesday. You can use your books, notes, homework, you can, just don't use each other.